Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Dave Aronson, who is the T-Rex, aka President, Owner, CEO, and Bottle Washer at Codosaurus LLC, a software development consultancy based in the United States. He's also the creator of the ACRUMEN Software Quality Framework. Dave Aronson, welcome to Maintainable.
Hi, Robby. Glad to be here.
So starting off, and this is a question I ask most of my guests, what do you believe are a few common characteristics of, dare I say, maintainable software?
Well, there are so many. It's hard to pick just a few, but I think starting from the high level, I would look at whether and how things are organized. Mainly, is everything just dumped into one big directory full of all kinds of different files for different purposes, or are they organized into the kinds or the purposes or some other thing that at least makes sense in context?
So you're talking a bit about file structure and organization of the code itself. And do you see that there's a lot of that within frameworks that help provide some guidance there?
Yes. In particular, ones with very strong opinions, such as Ruby on Rails, dictates, okay, you put all your app stuff under app and then divide that up into things for the controllers and models and views. Oh my. And there are various other assorted conventions. And I've seen a few other frameworks with other types of conventions and a few with no conventions, so you figure it out or you don't and just let it stay sloppy.
I remember the era of working in some web applications prior to, I used to do a lot of work with like PHP and Perl, and every app I worked on was drastically different based off of whatever the opinions of the developers that were working on that application prior to me. And then you would kind of follow those similar conventions for that application. I admittedly didn't really spend a lot of time thinking, maybe I need to go back and reorganize this because that always sounds like more work. But in my career, it was, being introduced to Ruby on Rails early on and just being like, wow, this made so many decisions for me that I may or may not agree with everything, but I don't have to make this decision anymore. And that frees me up to think about other problems in the application. But given your vast experience in the industry, have you seen a lot of those kind of framework type opinions throughout the history of your career, or has that been something you've seen more in the last few decades?
Well, my experience has mostly been without much use of frameworks. So most of the frameworks I've used have been either Rails, which has a lot of strong opinions itself, or Phoenix, which is so much patterned after Rails that, yes, it has strong opinions as well, and adds a few more, some of which I think would be useful to port back into Rails. Some of the others, such as Sinatra, are far less opinionated, but I had done that mostly after doing a lot of Rails, so I decided to just go with the way I know. There were some other projects that had lots and lots of files. In those cases, I usually divided them up first by purpose and then type of file, like the various components of the system, and then the .c files and .h files and so forth. Or sometimes the other way around when it's a system like C, where it's easier to just lump them all into a directory of include files. But anyway, in any event, some sort of way that makes sense within the context of organizing them.
Given your experience in the industry, and it's probably safe to assume that you've worked with a lot of different developers in some capacity, whether you're providing some consulting or they're on the same team as you, and hearing how people talk about things like maintainable software and technical debt, or maybe throwing around phrases like legacy code. What do you believe are some things that developers often get wrong when they're discussing technical debt amongst themselves and or with stakeholders?
I recently heard something that really resonated with me about technical debt. How a lot of people tend to assume that technical debt is always this evil, horrible thing to get rid of as much as you can, as soon as you can. Kill it with fire. But it's not necessarily always that bad, or even necessarily bad at all. One analogy I recently heard was that some technical debt is like various different forms of real world financial debt. Is this piece of technical debt that we're about to take on more like a mortgage, which is, frequently a great thing? It lets you buy a house. You can have that money still sitting around. Yes, you're paying around, say, 3% interest on it, but you can quite likely invest it at 5, maybe 10%. That's a great thing. Some on the other extreme are more like a payday loan. You're quite likely going to lose your car. In the middle, there are things like credit card. You can pay it off quickly and responsibly, and it can be an excellent tool to help the flow. Or you can let it pile up and abuse it and quite likely lose your car and your home.
So given these different metaphors, do you find that developers, when they're mislabeling things as technical debt, like say when it's just bad code, or if it's like, hey, this is outdated by a couple of versions, there's probably a lot of different examples, but what sorts of things do people tend to call technical debt?
Yes. Sometimes people do call some bad code technical debt, and that might not be quite correct in applying the label to the code, but it would be sort of correct to say that letting the code stay like that is a form of technical debt. Sort of like, I'm not going to pay off this purchase right now is, putting it on a credit card. That's a form of debt. There are, I suppose, other ways one could mislabel things as technical debt. Nothing really leaps to mind, but I'm sure somebody has.
Another recent conversation, I was interviewing Michael Feathers, and he describes legacy code as anything that doesn't have tests for it. And I thought that was an interesting take on that. There's probably some varying opinions about technical debt and legacy code. Have you seen teams as a consultant when you come in and they're like, we have this technical debt, or you're helping them identify technical debt, that you've been able to effectively help them prioritize that amongst the backlog of things that they're already trying to take care of?
Usually they've already got somewhat of a decent handle on the fact that there is some technical debt. The prioritization, that's where they sometimes need a little more of a hand, and the discovery of all the little nooks and crannies that technical debt may be hiding in. For instance, at my current primary client, one of the things I've been doing is to discover where there's some very definable technical debt, mostly things like, RuboCop reports 57,261 smells for this file, one of them being that it's so large. Then breaking it down into some reasonable chunks, like, make a ticket for this person to attack this category of smells, and then another person to attack another category, and then another person might address the things that another tool like Reek or whatever says is wrong with it from a different sort of angle than RuboCop looks at. We will occasionally also put real human judgment thought into looking at the possible hidden smells in ways that those automated tools will not so easily pick up, especially the relationships between the files, such as the overarching organization and so forth. And try and figure out, is this a form of debt that we really need to tackle right now? Or is this something with, I guess you could say, low enough interest rate on it that we can let it sit for a while?
I think it's interesting helping teams try to triage that and prioritize that. It's easy enough to come up with a big list of things, but then trying to figure out who's going to do it? How are we going to do it? In what order? Does it make sense? It's not always super obvious. And sometimes it just takes another independent person to come in and help make some decisions on your behalf. And then you're like, okay, this helps, because it could be potentially a little paralyzing as a developer to see we got 30,000 issues according to Code Climate in our application. Where do we start? My own company was talking to a potential client recently, and our contact was able to figure out how to get into Code Climate and run their own code base that their previous developers had worked on. Code Climate's reporting that's going to take 22 years to clean up the mess. And she's like, we only started this 3 years ago. we've already created 22 years worth of work. It can be hard for people to like really know what to even make of that. And obviously there's probably a lot more things they need to do in the configuration to get that number a little bit more accurate, but it can be a little daunting when you see such a big list of things.
Yes, I would seriously question that 22-year number. There's got to be, even if they just started rewriting it over and being more careful, it would be a lot quicker than 22 years, I would assume.
Yes. Let's pivot a little bit to a topic that I know that you've spoken a lot about, and I'm going to include a couple links to some of your videos in the show notes as well. Let's talk about software quality. First of all, what do you mean by software quality?
That's a nice softball question. That's one of the things that I actually address in the opening of the talks I give on this topic. A while back, I was looking for a good definition of software quality, and long story short, didn't find anything that either I liked or was commonly accepted. And in the spirit of the XKCD cartoon about the competing standards, I decided to, of course, make my own. And what I came up with is to address it from the angle of a list of aspects. And I've managed to boil it down to 6 aspects that I think cover the field of software quality pretty comprehensively. It's not meant to address the extreme high levels of quality needed in things like avionics and implanted medical devices and so forth, but for the vast majority of software, it needs to be appropriate, correct, robust, usable, maintainable, and efficient. And I package those up with the acronym ACRUMEN, try saying that 10 times fast, which, as you may have noticed, has an extra letter on the end. So what's the N stand for? Nothing. I just tacked that on to make a real word. So what is acrumen, the word? It's an ancient Latin word meaning sour fruit. So the official color of acrumen that I tend to use a lot in the slides is bright lemon yellow.
Sour. Okay. Let's dive into this a little bit. So what do you mean by acrumen, ACRUMEN, appropriate? And I think your short definition there was like doing the right job. What do you mean by that?
The slightly longer explanation is that it's doing what the stakeholders need it to do. And that's primarily the users, but we shouldn't lose sight of also the users and customers not necessarily being the same person. So, for instance, if you're writing some sort of enterprise application, your user is going to be some poor schlub stuck in a cubicle pounding away at your software, and the customer, the person paying for it, well, in one sense, the quote-unquote person, legally a person paying for it would be the company, but it's also likely to be whoever's in charge of the company budget and the people actually executing the purchases. So you have to take their needs into mind. And if you kind of sort of squint at the software sideways, then you can also cover a lot of other people under the whole rubric of stakeholders, such as the operations personnel. So software should be easy to operate, and that kind of also goes under the whole usability thing, treating operations people as a class of user, and similarly for upgradability, deployability, and so forth. And there's all sorts of other stakeholders one might be able to drag in.
Sure. How does this differentiate from, say, I know the next letter is C for correct, doing the right job. And so when you're talking about the appropriate, is it, you're trying to deliver on that business, whatever the, the user story or what have you in that example of, does it work? Does it meet the needs of that use case or what have you? And correct, how do you describe that? Doing the job the right way?
I sort of play up the similarity sometimes of do the right job versus do the job right, though I admit the similarity may be a little confusing for those who aren't native English speakers. Anyway, the differentiation is mainly, is it at least trying to do the job that is asked for it, and then is it doing that job correctly as opposed to just having some bugs. The usual example I use for appropriateness is if you ask me to write a checkers playing program, and I write you the world's greatest chess playing program. And it could be as correct, robust, usable, maintainable, and efficient as anyone could ever possibly want. But if you wanted a checkers program, you're not going to be happy with it because this is a chess program. It's not what you wanted. It's not what you asked for, or in ACRUMEN terms, it's not appropriate. As opposed to a perfectly reasonable checkers program that might not be utterly fantastic. It might even have a few bugs, but it's probably going to suit your needs a lot better than a fantastic chess program.
Yeah, that makes sense. When you're working with developers and kind of explain this, how do you validate that something is correct? Does it get into that there's like a methodology to how you code it? Does it get that low level, or is it more in the deliverable needs to be correct?
It's absolutely in the deliverable. I'm very deliberately trying to avoid being very, very prescriptive about how you go about it. I want this concept to be usable by people following any methodology or even no methodology at all in any language and so forth. So I don't want something that's going to be only applicable within the confines of an object-oriented system or whatever other sort of paradigm. So mainly whether it's correct depends on there being some standard of correctness to compare it to. For instance, do we have some kind of tests that embody requirements that were not necessarily formally signed off on, but at least in a general sense approved by the stakeholders? For instance, going back to the chess scenario, the checkers scenario, it shouldn't let you jump over an empty square. It shouldn't let you land on an occupied square, things like that.
That makes sense. Let's dive into robust.
The vast majority of what I mean by that is really more properly called security, but I wanted to form an acronym that would be pronounceable and ideally even a real word, hopefully one that some domain squatter hadn't jumped on yet. And there are a couple other things that I'm lumping in there as well. Let's first tackle the bit about security. And I usually explain that in terms of this concept from information security called the CIA triad. It's nothing to do with spies and gangsters. It's the concept of confidentiality, integrity, and availability. I'll go into that very briefly. It means basically that it should not reveal information when it's not supposed to, alter information when it's not supposed to, or become unavailable when it's not supposed to. And that may sound pretty simple, but there's a lot that can happen to make a system not uphold those. Your system can, for starters, it can get hacked. If there is some sort of security vulnerability there, somebody can get all kinds of information out of it, or, as a lot of people fail to realize, but is even worse, get bogus information into it. If you're a bank, you don't want somebody getting bogus information in there, such as a vastly increased balance that they can then come by and withdraw on.
So having a sense of some guardrails on both sides of that, make sure things are constraining access to data and who can read and write access and things of that nature.
Yes, assuming your system deals with any sort of information that should be subject to that sort of thing. That includes things like authentication and authorization and accounting and so forth. We could go on and on and on about security. There are a couple other things I want to talk about that I lump into robustness. The main one is showing uncaught, confusing error messages. Like if the system wants you to type a file name and you make a little typo, it should not Well, it certainly shouldn't crash. That counts as becoming unavailable when it's not supposed to. But it shouldn't give you some cryptic message like no-ent. A lot of people wouldn't even understand that that means error, no directory entry. A more cryptic way of saying file not found. It should just give a friendlier error message like, oh, I'm sorry, I couldn't find that file. Did you maybe make a typo? Please type it again.
Hear you there. I was literally an hour and a half ago, I was working with one of our junior developers debugging something, and I had to Google AWS ECS error 5 code exit. I'm like, what the? I still don't know what that means.
Yes. However, it is a fine balance between giving useful, helpful error messages to people who made some kind of legitimate mistake versus giving too much information to a potential attacker. It's for pretty good reasons that a lot of systems just give you a 404 file not found, as opposed to a complete stack trace and information on the versions of all components running and things like that. And that would be a goldmine to somebody trying to figure out how to hack into your system.
I'm having memories of seeing different PHP sites with showing like username information and hostname and database connection problems due to the credentials showing up in like the top of the header of a page or something. And you're just like, oh my gosh. Back in the day. So you talk about like robust and then as we navigate through this, is it easy for users to use? That's usable. Is there anything else in there in terms of how that relates to the developers as users of the code?
Well, one of the things that people often forget about usability is that it's not just the end user that needs to find it usable. Things like an API should be usable as well, whether that's binary API that works by function calls or library callbacks or whatever, or a over-the-wire protocol, whether it's something binary or a textual-based protocol like HTTP and whatnot. So that's one of the slides in my presentation, walking through those and web app and a mobile app and a desktop app and a command line app, even for those who remember those things. I still use them frequently, of course.
Of course. So maintainable is obviously very topical for this podcast. What does that mean within the context of ACRUMEN?
The very short explanation is that it's easy to change. I think we could all agree on that, but I try to take it a step further and say that it should be easy to change with low fear of error and low chance of error, even for a novice programmer who is new to our project. One of the good things is that the vast majority of software engineering advice is aimed squarely at this. It's stuff we've discovered for ourselves, for use by ourselves. I don't mean that we haven't stood on the shoulders of the previous generations of giants or anything like that. We are using these principles for our own work. So we tend to focus primarily on discovering these, as opposed to many developers might never give much of a thought to whether something's easy to use and whether it meets the needs of the stakeholders. In fact, many times we aren't even exposed to what the needs of the stakeholders are. Something I usually say in these presentations is that we're not usually taught that appropriateness is even a concept we should be thinking about.
When you talk about how we're not necessarily taught, appropriateness is something we're taught as we're learning to become a software developer. Is that because the perception of our industry is we are worker bees that get past tasks or small orders of things to deliver, and we're supposed to take the request at being the empirical, they've already thought through everything, so just turn this around and produce some code as a result of that?
I think it actually stems more from the, shall we say, less granular days of waterfall. A lot of systems back then, in fact, I'd say most systems back then tend to have been larger things where there might have been a more formal process, including a stage of requirements analysis. So the requirements analysts and the powers that be representing the company that's actually going to write this crazy thing have come up with this list of requirements. They throw it over the wall into the software department, and they go away for some number of months and then throw some supposedly working software over the wall to the QA department, and maybe some back and forth there, and eventually out to the shipping department. By contrast, today we are working in smaller chunks, which may mean a better opportunity for the developers to get involved and certainly to understand the requirements of a particular task at hand. They may sometimes be grouped into larger things, like stories grouped into epics and whatnot, that may require a little more interchange with the stakeholders to fully understand the intent. So sometimes that happens, but still frequently not.
It's been interesting over the years knowing that we want ideally, at least, I say this as an employer of developers myself, I want developers to be engaged with the stakeholders. I want them to understand what we're trying to deliver and understand the business value so they can be good advocates because they have a frontline view of what's going on under the hood of how things are. And not all developers know how to best speak with stakeholders in an efficient way or can relate to them in the same way and just be like, well, I'm just happy to keep focusing on my coding itself and I don't, just assume that they're right. And I'm always trying to be an advocate of being like, we're here to make sure our clients get what they need, not what they think they want. It's not always like a direct thing. And so we might build things that may not get used because it's not quite meeting their long-term needs. And so we're here to spot patterns, recognize that, and be an advocate for our clients, and to also pitch and propose alternate ways of looking at the problem. Like a really basic example that comes across pretty often is a client might ask for like a report, and there might be some existing reporting in the application. And so on this reports tab, can we add another report for this thing? I need to get a report for this upcoming presentation I'm going to be delivering. Okay. A week later, I find out that the developer spent a good chunk of time building a reporting tool that has a bunch of filtering things and is reusable. And then I find out that report's only needing to be run once.
Yes, they over-engineered it.
Well, they were like, maybe we'll use it again. And I'm like, did you ask them if they'll ever need to do that again? And they're like, no. So when those sorts of things happen, I'm like, we could have maybe just produced the report for them. That could have been like an Excel file. Because like now we have code to maintain that we're going to worry to make changes to that may never get used again. And it sits there. And I'm glad we got a bunch of testing and everything for this, but will it be used again? Those sorts of things people have to pick up at some point. I learned that as a developer because I built up a bunch of things and over the following years, realized nobody's using this stuff anymore. So I could have spent my time doing something else. I could have delivered something else of value to them with the time that I spent there. But sometimes it's not always easy to learn through other people's stories, I suppose. But that was my own reflection there. Moving back into ACRUMEN. So what do you mean by efficient? Is that CPU cycles or something a little bit more substantial than that?
Well, the usual case that people tend to think of is indeed CPU cycles. We're generally taught in school about efficient algorithms and data structures that go along with them. But there are a number of other resources I think we should make efficient use of, technical and otherwise. Of course, we should make reasonably efficient use of even disk space now that it's so much cheaper than a few decades ago, and of network bandwidth and so forth, but also things like the user's patience and brain power and the company's money. Now, I know I didn't point this out earlier. I suppose I should have. There is often quite a lot of overlap between these aspects. The parts about user patience and brain power have significant effect also on the usability. I'm sure you've often said, oh, this software is so horribly unusable. I'm just sitting here getting so impatient with it. It's abusing and draining your patience, being inefficient with that resource. I know it may be a little unusual to think of it as a drainable resource. thereby also having the effect on the usability. So, for instance, we could have a system that generates a report, and the user might be able to sit there and read it on the screen, or they might want to download it as a PDF. But that might take a few minutes or maybe even several minutes to generate. And it would be obviously taxing on their patience to make them sit there and wait through that, especially if they cannot then use the app further to do something else while the PDF is generating. So we can save their patience in any number of ways, primarily by putting the requests in a queue to generate either in the background or on a separate system, even overnight if it's low enough priority. And then we can either send them some kind of message with a link to it, or if we have their email address, just email them the report directly. And that'll also save the resource of our disk space.
Yeah, that's great. I'm thinking about how, when should this happen? Should this happen now? Should this happen later? Not interrupting their workflow. They might need this report, but it may not need to lock the application, depending, I'm making a lot of assumptions coming from the web world where, might have a web application and it's going to take a little bit of time maybe to generate that. And you're not going to sit there watching a little spinner for too long. It frustrates me when applications are like, please hold. And you're like, and then you get nervous if you can even leave the tab or something. And then also when it comes to usability, how that kind of relates there, it's like, is this simple enough for someone to complete this task without having to burn too many mental calories necessarily? And that's kind of like a metaphor that I've heard in some other industries. So it's taking too many calories for me to figure out how to use this thing. And if I eat a bigger lunch, it's not going to help me get through this process. We'll be back with my interview with Dave in just a moment. Hi, it's me, Robby. I want to thank you for listening to the Maintainable Software Podcast. I'm doing a little happy dance. Clapping. Oh yeah. Thank you for listening. Anyways, if you're finding these discussions valuable, please consider sharing it amongst your peers and or writing a review on Apple Podcasts to help spread the word. And now, back to our interview with Dave Aronson. As this acronym, ACRUMEN, is there any inherent order to this in terms of prioritization, or do you feel like they all have a fairly equal-ish ranking?
Well, I put them in that order for a reason. They're not always necessarily going to be in exactly that order, but I think appropriateness is always going to be at the top. I think that example with the really great chess program not being satisfactory for someone who just wanted a simple checkers program kind of proves the point that appropriateness is not only more important than any one of the others, but more important than all the rest put together. So that's always going to be number one. The rest of them, they could get scrambled quite a bit. There's an example I use sometimes of a purely internal number crunching command line tool for some algorithm that's never going to change, like some law of physics or something. And we can ignore quantum revelations and whatnot, changing what we know of the laws of physics. But let's suppose that's not going to change. Its list may well look more like appropriateness, efficiency, usability, correctness, robustness, maintainability. ACRUMEN rather than ACRUMEN.
Do you have any advice for developers, as they're looking at a user story later in the day, after they've went on a dog walk and listened to our great conversation here, and they're like, the approach I'm thinking about taking for building out this new set of features, is it appropriate? What are a few questions they could quickly ask themselves to validate that, not only with themselves, but maybe with the stakeholders?
They can clarify their understanding of it with the stakeholders. Now, ideally, they're using one of those agile processes and whatnot that incorporate close, frequent stakeholder contact. Now, I know that's often not reality, but it is an ideal. And ask If the goal they have in mind for this thing is really what they meant, try to put it in different words and verify whether it's what the stakeholders were thinking. Now, if a task is so complex as to really need that, some might say it ought to actually be broken up into smaller pieces first. But then you might have the same question about this whole collection of tasks. So you can't really get out of it that easily. I guess the lesson there is don't necessarily wait till it's down at the individual task level to validate your understanding of what they need. Come to think of it, one thing I forgot to mention here is that rather than just asking what they want, take it a little step further and ask why they want things. And that'll get at various levels of what they really need as opposed to what they want or what they say they want. I'm sure you've seen that illustration of the tire swing, what the customer said they wanted, how the architects planned it, how it got installed and whatnot. And in the end, what the customer really wanted was just a simple tire swing.
Yeah, that's a good one. You think about, asking them why they want something. I know that another guest not that long ago, Liz Keogh, I think, she advocated for kind of following up with that with maybe also asking, why do they want this? Or can you give me an example of how this would be used? You can kind of talk about a story or a use case that you can then use to maybe help you indicate how you might write tests, assuming that you go through that process. Hopefully you do. But then when you come back and like, hey, and that's example you shared where you said, the VP of marketing would go into the application and do this thing. You can think about it a little bit differently because you're now able to talk about that example and not like just the inputs and outputs of the requirements themselves.
Mm-hmm. Yes, there's all kinds of things you can do with user personas and whatnot there.
Right. So a couple of quick things I wanted to touch on is some like rapid fire questions for you. Do you find yourself more often on team rewrite or team refactor?
I'm usually on team refactor for small things. If there's just some little bit of smelly code, so small as to be downright trivial that refactor would be tantamount to a rewrite. But it can occasionally get to such a big smelly pile that, there's not much short of a rewrite that's going to fix this.
And how did your company name come about?
I originally thought up Codosaurus as the name of my blog. If I remember rightly, you have interviewed Brian Lyles, correct?
Yes.
He was offering advice for people who wanted to break into Ruby. And at the time, I was working mostly I had recently broken out of what I called the plain old C rut and had gotten a job with, a little Ruby, mostly Perl, some Python. I really liked Ruby and wanted to break more into that. And the main advice he gave me was to start blogging. And at the time, I was feeling a little obsolete, having recently broken out of that plain old C rut and so forth. And after considering a number of other such things that combined code, computer, program, engineer, whatever, versus something connoting obsolescence. Code, dinosaur, Codosaurus. There we go. And it even ends in US, so I can use a .us domain. And I Googled it. The only thing I found was somebody referring to a very large cod he had caught. So I thought it was safe to go ahead and registered that domain for my blog. Then when I eventually went freelance, I decided, I've already got this cool domain name. People seem to like it. Well, make that the company name. I even went online and found a couple cute drawings of dinosaurs using computers that I got permission to use for my logo for a while.
That's great. So a little bit of a domain availability driven development. What is your favorite type of dinosaur?
Well, I am officially the T-Rex of my company, so I guess I would say the T-Rex. Yeah, he has a good excuse not to do push-ups, too.
I'm a fan of Brachiosaurus.
There was actually a comedian who did a bit a while back on what was the best dinosaur. He was going through all kinds of ones suggested by the audience. That's not great. Oh, Velociraptor? No, that's not from Jurassic Park. Those are Deinonychus. Velociraptor is really about the size of a chicken. I could just kick that thing. It was amusing in a geeky kind of way.
The back of my apartment overlooks like a pretty popular art street in Portland, Oregon. It's very visible from the street. And so for a while, I had a 12-foot long Brachiosaurus inflatable dinosaur in the back patio as like a art installation piece until it got stolen. And then I got a replacement. I geek out a little bit about dinosaurs. Because of that, I have like these little dinosaur figurines kind of around, and I'm showing you over the video, but no one else will see this. But people just give me dinosaur stuff now.
Cool.
So a couple of last quick questions for you. What non-programming book, it could still be technical, do you find yourself most often recommending to people in your industry? It doesn't necessarily need to be a coding book.
Well, if it's not a coding book, but still allowed to be at least somewhat technical, I think The Pragmatic Programmer, it does not contain anything about a specific piece of code, but lots and lots of advice on how to manage your career, how to write maintainable software, and other very useful things without getting too down in the weeds.
And what is your cat's name?
I currently have Petey crawling around my legs, and Nina was here earlier, but I don't think she is anymore. And you can find some amusing videos of Petey playing fetch or chasing his tail. Yes, he's a cat, not a dog, on YouTube on my channel.
Where can listeners best follow your thoughts on software development online? Is that codosaurus.us?
I'm slowly transferring my blog over from blog.codosaur.us to codosaur.us/blog. The old one's on Blogger. The new thing is part of a Jekyll site. But I haven't been blogging much over the past few years, so that might not be such a great way to follow my thoughts. I've probably been a lot more active on Twitter lately, and my handle is just Dave Aronson, DaveAronson. I hang out on assorted LinkedIn groups. I have been a lot less active there over the past few years, too. Don't get me started on what LinkedIn has done to their groups. Yeah, I'd say the main starting point would probably be Twitter, and sort of branch out from there as I announce availability of new videos or something like that, or that I'm going to be at some conference.
Well, it's been such a delight having you on Maintainable, Dave. Thank you for joining us today and for introducing ACRUMEN to a lot of those that are listening that may not have heard of it yet.
Okay, well, thank you for having me on. Always glad to spread this ACRUMEN crazy idea.